Welcome to Mining Over Canada. Join the Canadian Securities Exchange and our partners in a first-hand look into our country's vast mining landscape. Experience its regions, meet the people, explore the history, and find out what comes next in one of Canada's richest industries.
Hello, everyone, and welcome to another Tech Tuesday. I'm Grace Pedota from the Canadian Securities Exchange, and I am welcoming you to our weekly Tech Tuesday event. This week, we are featuring mining technology companies within the private sector. I am going to post a link in the chat channel that will be a link to CSE TV on YouTube, where you can find this content, and as well as I will be featuring a link to register for Mining Over Canada. So this is a new initiative at the CSE, and if you click the link to register, you can keep up to date with all of the great content within the mining sector. And without further ado, I will introduce our moderator today, Mark Francis.
Thank you, Grace. Everyone online for joining us live today, as with every Tuesday, starting 15 minutes after market close, with companies at various stages from North America and abroad. Next week, October 27th, we still have content to be announced, and November 3rd, we will return to the mining theme by featuring CSE listed companies with unique, environmentally beneficial metallurgical technology. So first today, a segue about the challenges of introducing innovation in the mining industry. On the exploration side, where there are no cascading punishments for being wrong, industry has fearlessly created and adapted technology. Two examples would be the adoption of geophysics and an ever more complex and clever versions, and the astounding processes for harvesting unique information from soil samples to determine what might lie hundreds of meters beneath. Even using bacterial waste streams to identify specific potential mineralization. But when it comes to mining operations, where each deposit is unique, and with large lenders concerned about risk and having effective operational vetoes, governments concerned about environmental impacts of practices, and industry safety associations with high standards, implementing something new must be done very carefully and precisely. And the challenge is that changing one item in the middle of a mining operation triggers multiple changes elsewhere. Furthermore, running financial losses almost invariably correlates with higher safety and environmental risks, and an inability to adapt new technologies, which require capital investment. So adoption of a technology which doesn't work can endanger an entire operation. One example comes to mind. In the 1990s, a very smart person came up with a unique way of treating vanadium wastes. Vanadium being a not so nice metal for the environment and life in general when it isn't being used in the right application, and which are found in oil sands tailings. This major company let the innovator onto their property, and when the process didn't work properly on a commercial scale in that particular application with those particular gang minerals around it, the result was an environmental catastrophe, cleanup costs well into the tens of millions and possibly higher. Caution is mandatory. There are inherent reasons why it took the mining industry several attempts to introduce its first all-electric mine, with then Goldcorp being the one that finally succeeded at the Borden mine in Ontario just a few years ago. But the industry is constantly innovating and working to do things better and smarter, and presenting today, we have three great examples of innovation in mining. Our objective in running Tech Tuesdays is twofold. First, to help technology companies with increasing traction to gain relevant visibility, and second, to help capital markets players by introducing interesting companies focusing on whether the technology will have commercial traction and why, and also providing new knowledge of what is happening in innovation. For you as attendees, we do ask that you share ideas and your feedback with our presenters, including leads, possibly funding after due diligence, referral of someone with unique applicable expertise, or maybe even a potential strategic relationship. You can find their contact information in the chat board. With respect, we might refrain from giving management advice unless we are truly experts in the company's particular field, and don't treat our presenting companies as marketing targets for services. Couple of housekeeping matters. You may note a red Reconnect tab appear at the top of your screen. If you lose audio, just click it and you will be reconnected. In the event there are technical problems, we may hit the restart, in which case there's no action required by you, as the system will automatically reconnect everyone. We aim to run 45 minutes to 1 hour, and the chat board may be utilized to ask serious questions. Please be clear as to whom your question is being addressed, and Angela will try to get to them. Note our disclaimer. This presentation is for information only and is not a solicitation to make an investment in either shares or debt or to buy or sell stock. CSE and Mark Francis, as session host, i.e. yours truly, make no representation about any of these companies. If you are interested in the investor pitch, please connect with the companies directly in order to get detailed information. Each company will have a 7-minute presentation with their PowerPoint. When you see my face appear, the company has 15 seconds to wrap up. After all companies have presented, we will move to Q&A, today led by Angela Jackson of Portland Seed Fund. And I would be remiss for not publicly thanking Alistair Ross, CEO of Rockcliffe Metals, RCLF on CSE, who is truly on the forefront of change in the mining industry and is leading a team which is planning mine developments which will draw together many relatively new technologies and innovations from the very outset. So today we have as presenters Amanda Truscott, based in Montreal, co-founder and CEO of Rithmik Solutions, nominated by Valhalla Angels. Jack Cahn of Lunenburg, Nova Scotia, founder and CEO, Deep Cryogenics, referred by Alistair Ross. And Rod Steele in Sudbury, founder and CEO of TesMan, also referred by Alistair Ross. So let's start with Amanda Truscott. Amanda Truscott is co-founder and CEO of Rithmik Solutions, which increases mine uptime and lowers emissions with advanced analytics that optimize maintenance, extend equipment life, and reduce fuel consumption. Amanda specializes in technology-related communications. She has designed and developed training and customer onboarding programs for several industrial process software applications. It's all yours, Amanda.
Thanks so much, Mark. Really appreciate the opportunity to be here. So hello, everyone. As Mark said, my name's Amanda, and I'm the CEO at Rithmik Solutions. We increase uptime in mines, as Mark was saying, with analytics that optimize maintenance, reduce greenhouse gas emissions, and extend the life of equipment. So pictured with me here are my co-founders, Chris Isfeld and Kevin Urbanski. We started the company in 2018, but the story actually begins about a decade earlier at an industrial process software company called Cahn, which some of you might know. All three of us used to work there. And Kevin and Chris were two of the key players behind that company's mobile equipment monitor product, which was one of the earliest data collection and reporting systems for mobile mining equipment. It's now owned by Honeywell. And through their work with MEM, the guys spent many years traveling to mines all over North and South America. They froze their fingers on shovels in minus 30 degrees Celsius. They got heat stroke in Baghdad, Arizona, and they became intimately familiar with every brand of mobile mining equipment in surface mines, and some in underground as well, in ways that very few people in the world ever get to be. And there were a lot of challenges with that equipment. After Cahn, Kevin worked at Tech Resources, and while he was there, he saw how many challenges there still were in spite of the good data that they were getting. Because good data actually isn't enough, or another way to look at it is actually that it's too much. One haul truck, for example, might have around 150 sensors, and if you've got one person keeping track of 50 of those, that's many thousands of data points that they're looking at. And then you have manufacturer alarms that are so frequent, they end up becoming noise. And that's why quite often you'll see things like an oil pump failure that goes undetected and then as a result ends up leading to an engine failure, at which point you're looking at $2 million in lost revenue and maintenance costs, as opposed to the 30,000 that you would have been looking at if you had just been able to replace the oil pump in time. And that's why even though most of the bigger mining companies are collecting data now, and some of them are even doing some advanced analytics, they're still struggling to make enough sense of that data to prevent catastrophic equipment failures. And that's why they're still spending anywhere between 20 and 50% of their annual operating budgets on maintenance, with reduced revenue from all that downtime having an even bigger financial impact. So after tech, Kevin took a sabbatical to study artificial intelligence and machine learning. And that's when he understood that these were the methods that could finally take all of that data that he and Chris had worked so hard to get for the mines and turn it into actionable information. So Kevin started Rithmik, and Chris and I jumped on board. Chris was as excited as Kevin to finish what they had started. And for my part, I really wanted to build a company where the sort of collaboration that I saw between the two of them was the norm. We also all wanted to help the planet, and increasing the efficiency of mining equipment provides a really huge opportunity to do that. According to a study published in the Journal of Sustainable Mining, when you increase the reliability of a mining haul truck from 60% to 75%, you decrease its fuel consumption and greenhouse gas emissions by 15.6%. So what we've developed is a product called Asset Health Analyzer, AHA for short. It uses machine learning to automatically sift through all of that data and draw people's attention to precisely where the issues are. And it does that early enough so that mines can take action to prevent small problems from turning into big problems. And it does all of that in a very unique way, because throughout AHA's development, we kept in mind the fact that, as Mark was alluding to, there is arguably nowhere in the world where deploying new technologies is tougher than it is in a mine. And in addition to some of the reasons that Mark listed, you're also dealing with things like constant topographic changes, extreme high and low temperatures, and in a lot of cases, you're also facing some resistance from people when it comes to implementing new systems. So we're addressing those challenges in a number of ways. Underlying our Asset Health Analyzer is a rapid analytics infrastructure that lets us tune our AI models to a specific environment in less than a week. And the reason we do that is that the same sensor values on the same models of equipment can actually mean very different things depending on the part of the world that you're in, what season it is, and the type of material that you're moving, which means that the kind of cookie cutter approach to artificial intelligence that might work in something like a fixed plant just doesn't work when you're dealing with mobile mining equipment. And our product takes that into account. As well, something that we've seen a lot of in mines is screen anxiety. People have way too many things to pay attention to. And even though they need better insights, very often the last thing they want is to add yet another tool to the stack of things they're already using. So we built AHA to work with whatever the data mines are already collecting and to feed its insights through the tools they're already using. And if they don't have those reporting tools in place, then we feed the insights through Grafana, which is a really flexible and intuitive third-party interface. So where we're at now, we have completed successful proofs of concept with multiple brands of mobile equipment using data from several different mines. Just one of the many examples of the results that we've seen involved rod-bearing failures on Cat 793Ds that were costing a site in BC about $4 million a year because the only warning they were getting was a Cat-generated alarm just a few minutes before the failure. And AHA found indicators of those failures 10 hours in advance. Another example were some drive system issues that we found with Komatsu 930Es. That was at a different site. And those failures were costing $1.4 million a year because they weren't getting data from the affected subsystem. And AHA was able to find indirect indicators of those failures in the engine's operating behavior. And it found them days in advance. So we're now completing real-time on-site implementations of our solution in Canada. And we're also in discussions with prospects in Australia, South America, and Africa. Right now, we're raising $1.5 million US to accelerate our international commercialization. So if there's anyone who would like to hear the investor pitch, please do reach out. Here's my contact info. And if you would like to talk in more detail as well about our Asset Health Analyzer, or if you'd like to see a demo, I am happy to have those conversations as well. Thanks very much. And that's it.
Thank you, Amanda. You're ahead of schedule. And now Jack Cahn. Jack is the founder and principal researcher at Deep Cryogenics International. Since 1999, he has used DCT on machine shop tooling, on several mining products, developed DC test procedures for use on JPL's Mars exploration rover, and served as the lead investigator in 2 US Army R&D projects. He is the author of multiple DCT patents and research studies. And as we have a few extra seconds, I'll mention that one of the most popular talks ever at the Saskatchewan Geological Open House was when they had the Mars rover presentation talking about the geology they'd found. So Jack, you played a role in that, and thank you. Over to you.
Thanks very much, Mark. Yeah, I did play a role in that. We built quite a few of the instruments for Jet Propulsion Lab using deep cryogenically treated titanium. And that was where I first became familiar with this technology many years ago in 1998. And I was looking for a way of increasing the wear life of the consumable tooling that I was using in my high precision machine shop. And so over the next 2 years, I treated approximately 6,000 pieces of tooling as an end customer of this process, and found that I never had less than 30% and usually never more than 70% improvement on my tooling. But that led me into developing the technology for the mining community. One of the issues in mining is everything wears out. High abrasive wear, the intersection between abrasive wear and corrosion, known as tribocorrosion, short life on ground engagement tools, drills, mill liners, crusher cones, and pumps. This is common among every mine, no matter what material, no matter where they're located. And downtime is a huge issue. Maintenance is constant. And there's, of course, a tremendous risk to miners when catastrophic failures happen. After COVID, financial impact is even bigger than before. So what is deep cryogenics? It is essentially a cold thermal process that picks up after heat treating that allows an item to last approximately 20 to 70% longer in its abrasive wear life than it did when it was just heat treated. The process is very fast. It's extremely effective. It's low cost. And lastly, it's environmentally sound. Generally speaking, you're going to get 20 to 70% improvement across all types of materials that are ferric. Some non-ferrous materials, but mostly those hardened materials that are used extensively throughout mining products. And what happens during this process, which is a diffusionless kinetic process, is effectively the grain structure gets a little bit smaller. There's a switch from an austenite to a martensite structure. Carbide particles precipitate out through the matrix, and they act as abrasion resistant components within the metal to be able to stop it from wearing down at the same rate that is normal for most OEM or even aftermarket parts. Most of these items can be treated in raw material stage, as castings or as forgings, or even as finished parts supplied by an OEM. The advantage of the process is that it only costs about 10% of the original item to get between 20 and 70% life extension. So you're never upside down, you're always on the positive side. It doesn't change dimensional size, it leaves no chemicals or waste behind, and it's actually employed currently in lots of different automotive, engine, machining applications. It's currently on the forefront in mining, in marine, and we're using it on wind turbines as well. So with all that said, why has it not been explored further? One thing is that the technology is only about 100 years old compared with heat treating, which is almost 14,000 years old. And it has not been test available or have an industrial prove out for it until very recently. Just this past year, we were able to generate an X-ray diffraction certification procedure so it can be adopted in industry the same way medicines go through FDC or airline components go through an FAA certification. Now we've developed that certification. Finally, scale-up equipment is going to be made available for the mining industry beginning next summer. So the way that the process works is that over a period of about 8 hours, items are slow cooled in a tank, and then for a period of about a day, they undergo this cold thermal process. Many thousands of pounds can be treated simultaneously, and the entire process takes about 3 days. Seen in these slides are the target items that could be treated: crusher cones, slurry pumps, mill liners, drill bits, and gears. Currently, we have customers in mining who are trying out the process, and many who have already tried it out and are now starting to do some production work. We're also engaged with the Canadian Coast Guard to treat a variety of different chain components, and with one of the larger manufacturers of wind turbines, Vestas. So the technology is a step change, because almost all metal parts in mining are currently only heat treated. None of them are deep cryogenically treated. The improvement they get is 10 to 30%, and there are about 14,000 shops worldwide that provide that service. We see the opportunity with deep cryogenic treatment, which is after heat treat, to add almost 25% to the existing market. And because the improvement is so much more than is available with heat treat, it's a very significant opportunity. There are only 20 shops worldwide, so it truly is a blue ocean opportunity. The company has been around since 2010. We incorporated in 2019 in Canada, and we did our original work making our bones, doing prove out on the technology with MIT and Rolls-Royce, and through numerous US Army studies. It's recommended heavily by NIST. We have several patents and those pending. We also have a recent certification on the items, as well as also our trademark, which is making things last longer. And we have a pretty good advisory group with Rob Stevens, formerly of Tech, Alistair Ross, who's been mentioned several times, and Hanny Hennian from the University of Alberta, a materials scientist and senior professor. And our technology really is all about that intersection between lowering carbon footprint, reducing the use of diesel to resupply items, increasing the safety for miners who might otherwise be exposed to items that when they reach the end of their part life, like Amanda said, it could be very sudden. Production, increasing uptime of items, reducing downtime, and lastly, lowering consumable cost. Thank you very much.
Thank you, Jack. Well done. And now Rod Steele. Rod is a mining and processing engineer with electronics experience and deeper underground hard rock mining operations management. His first career took him to North America, Africa, Australia, and Europe. His second, in Sudbury, has been as co-owner with Claire Steele and also the technical lead of TesMan, consultant on process design and implementation, a technology solutions provider. Rod, it's yours.
Thanks very much, Mark. So we're a small company in Sudbury. Our website's there if you're looking for information to contact us. And what I want to talk to you about today is what we're doing to improve the mine tunneling cycle, both safety and economics. So typical drill and blast tunneling in mines, as opposed to mechanical rock breaking in more civil tunnels. You've got a typical blast cycle of mucking the blasted material from the face, supporting the ground, preparing it to be drilled again safely, marking it up, drilling it, typically about 5-meter depth holes in North American and Australian mines. Clean the holes, load them with explosives, sequence the connection and detonators depending on what you found in the conditions in the holes. Blast it, ventilate the tunnel so that people can re-access. And behind that, you're advancing service lines, which is basically the energy for the process. Communication, ventilation, drain water, compressed air, and process water. In the present cycle today, personnel are at the face 100% of the cycle. I call that the capability limit, is how much of the work is actually done at the face and how much can be done behind the face, and I'll talk about that just now. That is actually how we strategically are planning on reducing the cycle. If you sum all the cycle tasks that I've described, typically in Australian, North American mines right now, and you take the delays out, which might be waiting for equipment, the face is inactive, etc. The benchmark is about 17 hours per individual face. We're going to talk in terms of advance of individual faces, because you can build your whole mine cycle of multiple faces based on your capability, coming back to the capability element of how long it actually takes you to do a single face. So the faster you can go on a single face, the more you can gain productivity-wise on the many faces. So our technology that we focused on is remote explosive cleaning and loading. So after the drill holes have been drilled, we've got to clean them out, load the explosives. And today, the operator is at the face for that entire process. And I should also mention that after a number of accidents and incidents and risk at the face, a lot of operators and mines nowadays are actually putting screen support on the faces. Probably in about the last 5 years, we've seen that more and more. Technology exists today if you want to remove the operators 5 meters back from the face on all of the other tasks, I should say most of the other tasks, except the drill hole cleaning and explosive loading. So we chose that niche to focus on because it would then enable the operator to be 6 meters back from the face, which is outside of the 5 meter offset from the face, to complete the drill hole cleaning and explosive loading. The relevance, again, just to remind you of the 5 meters, is that that's a typical single round advance. Obviously, the technology is scalable if we're going for longer advances or larger. So I'm going to be showing you examples of our small footprint design, which is our first one. And the other element that we are focusing heavily on is producing data-assisted loading for daily planning of tasks in the mines. So referring to one of the companies earlier on in the presentation, there is a lot of data. If you have the right data coming out, and if you can analyze it correctly and filter out what the right data is for the decision you're trying to make, then you're actually process improving dramatically. And more importantly, you can steer the entire ship in the direction of productivity or safety that you're aiming for. So I'm going to show you a series of pictures now so you can get a visual. What you can see here is a very small footprint vehicle. It's only about 60 inches wide. This one is made by Minecat. You can see this explosives tank on the back. This one actually has tractor arms instead of a boom. So it's suitable for gold mining, which is a narrow vein all the way up to bulk mining, base metals, etc. And the technology that we have is predominantly this orange arm assembly, robotic arm assembly with the operator station on the quick connect on the front of the operator basket. This is just to show what typically it looks like inside of a tunnel environment. So you can actually see a 16 by 16 foot dimension tunnel, or close to 5 by 5 meters. This would probably be on the bottom end of the larger diameter headings. You are looking at considerably narrower than this for the gold. It would be fitting in fairly snugly in a gold mining typical application. This is just a render, just to show that extent of the products you can put through the single arm at the same time. So we have patents around elements of the cleaning and the vision systems that we use on it. And one of them is that we can actually run multiple tools, multiple cleaning and loading tools through the same single point into the face. In this case, I'm just showing a simple render of a bulk emulsion tank and a bulk ampho tank, both of which we tested on this kind of platform. The question would come up, can we use other platforms? The answer is yes. Essentially, where you see the blue basket and the render of the arm can attach to any basket, any boom, any tractor arms on any make and model. This is a photograph showing a couple of guys in the operators in the basket. And the basket has no canopy, which is not very typical nowadays. The reason why there is no canopy on this particular basket is because in working with the mining clients through the testing phase, we got to a point where the operators are 6 meters away from the face. And so the need for the canopy was nullified. This may or may not be true in highly seismic events, depends on your safety zone. But this is actually showing the arm extended out, and you can just see the tip of the loading arm going towards the face. This is an unbolted face, and it's extending ahead of the ground support. This was a round that had broken ahead and had very bad ground, lost a couple of holes, so we had to come back in and reload a couple of holes. And you can see them up on the top of the face, and hence the unground supported. We were able just to drive back in, clean, load, and fire them again. So what are the benefits of a 5-meter cycle, and why are we now testing it in 2020 in the Sudbury Basin in one of the local mines? The first one is it removes the operator 6 meters from the risk exposure at the tunnel face in all conditions. And in Canadian mines, what's pertinent, more so than some of the shallower mines, is that they're deeper. In the basin, we're actually looking at getting down to 18,000 feet. The person is removed from the face, and also the potential for staggering the ground support and reducing the cycle from 17 hours to 11. This is what it opens the door to, which will be another cycle in 2022. And that would be fully teleremote capable cycle that could be run from surface. And the potential is to reduce the cycle further from 11 hours down to a stretch of 6 hours.
Very good. Rod, I'm afraid we're past the time.
That's fine. Thank you very much.
Very good. Thank you, Rod. Now we will bring back all of our panelists for the Inquisition. And today we have as question moderator, Angela Jackson, CEO of the Portland Seed Fund, and one of the best known participants in the US angel investor space. Angela looks at hundreds of investment opportunities in various technologies each year, runs a team that reviews and makes investment decisions, and we are delighted to have her with us today. Angela, you are in charge.
Thank you so much, Mark, for that warm introduction. And I want to compliment all three presenters on excellent presentations. I learned a lot, and I thought you did a wonderful job. So what I'd like to do with this Q&A session is generally to start with questions that are relevant for most or all of you, and then I'll kind of cue you to answer these. I might throw something at you that you didn't expect, but trust me, I think you're up for it. So let me start with just an easy observation, I guess, is it's super clear from the products and technologies you're bringing to the market that you are part of this wave of greatly enhancing the safety of the mining industry. So why don't we go in reverse order of presenters, starting with Rod. And I'd like to give you just another minute to expand on where, some of the specific enhancements and impacts to safety in the industry your particular technology is responsible for.
So I would say that the primary one is probably the safety element, which is becoming more and more serious as the sort of moral standards around the world raise towards the labor that are involved in mining. So being able to remove the person from the risk zone would be the first massive gain. The second one is productivity. And essentially, if you're a 17-hour cycle now, one of the most expensive elements of starting a mine, for example, it applies to all stages of the mine, but the early stage is to get to the ore body as fast as possible, open it up and get the ore to surface, so that you can start paying the bank back the $1 billion that got you to the ore. And if you can increase the rate, and they call it rapid development, by 35%, essentially you're saving about 35% of the investment to move those tunnels through, which is in the millions and hundreds of millions, depending on the mine that's in use. I would have to say those are the two that are probably the predominant chases that we're after.
Very good. Very good. Thank you. Okay, let's again go reverse order. Jack, what is your company's contribution to the safety in the industry?
Well, deep cryogenics extends the wear life of almost every item in a mine that is involved in any kind of wear. Therefore, whether it's a hauler vehicle or a conveyor or a crusher cone or any components, bearings or gears, anything that requires replacement requires the activity of a miner or a maintenance person to be able to go in, remove items that have worn out and then need to be replaced. So what our process does is it makes them last longer. In doing so, it reduces the amount of inventory, the amount of consumables, and the amount of man hours that are in an exposed position replacing what sometimes are items that have catastrophic failure Amanda was talking about being able to know when items fail. Well, if you could extend the life of those items, both the software that she provides, as well as also the amount of material that has to be held in a mine can be reduced extensively. It translates into money across all things because it's a agnostic process. It doesn't apply specifically to any one material. So I'll leave it there.
Excellent. Thank you. And Amanda.
Yeah, so I mean, a lot of what Jack said does apply to our system as well, even though they're very different products. We're looking at making things last a lot longer so that you have less maintenance overall that is having to happen, fewer people who are in there getting their hands dirty and exposing themselves to risk. But also we're looking at preventing those catastrophic failures and addressing issues when they're small issues as opposed to when they become big issues. And really the bigger the failure, the bigger the risk is. So there's that aspect as well.
Excellent. Thank you all. Next, I'd like to talk a little bit about the process of commercializing your technology. I think a very different path for everybody. And, you know, as I invest early, we always look at that product market fit. Something can be great in a lab or great in people's minds, but does the customer want it? And how do you sort of scale into sales and actual customer relationships? So may I start with Amanda, and we'll mix it up each time. We'll start with Amanda this one.
Yeah, so we're seeing a lot of enthusiasm for our product in all the mines that we talk to. Pretty much the obstacle has really been in terms of the procurement process and the length of time that it takes to go through that. And so we're working with channel partners now to really help to expedite that so that we're not having to go through that clunky process every single time. So for example, we have a technology solutions integrator who's selling us in Western Canada because he's already got the vendor numbers with everyone. That makes it a lot easier. I don't know if that answers your whole question. Is there a part that I missed?
I'll come back to that. I'm actually I liked what you said about procurement, and I'm gonna switch gears a little bit for you two. That is a really, I'm sure, very real problem, procurement and supply chain in COVID with, you know, altering shipping, ability to ship, interact, manufacture. So Jack, what about you? Is there any issue with procurement and supply chain related to COVID or otherwise that is something you're dealing with?
Well, sure. Procurement, people buy things that are going to work. And this is a new technology. So it's very difficult for someone to put their hands on something that's essentially an invisible process. So we have the only deep cryogenic research lab in the world. And that's been a big part of our company. When we started, I'm a pretty conservative guy. So we invested right back into our company. And we have a huge research and development lab here that's completely paid for. So at this point, what we did was lower our exposure going forward by making sure that our house was in order scientifically and engineering-wise with our process before we went to visit our customers. And whether we started with MIT or Rolls-Royce or with other companies to vet us third party, we made sure that our technology was tight. So yes, there's an issue with procurement right now. Mines are very risk adverse, as they should be. And we're trying to do our best to do that type of research and development on site here before we give parts to customers, before we solicit their business. We want to make sure that we've mitigated that risk before they come calling.
Thank you for that. Rod.
I would have to probably say the same thing in a different fashion and with a strange accent as my two partners there. So in order to prove a new technology for us, we first developed the technology, we prototyped it. We then went through the phase of actually using it in production. And in all of those phases, which was prior to this year in COVID, we were relying on mining partners. But as we went along, the equation gets a little bit more expensive because, for example, if, you're looking at $1.5 million to do 500 to 700 feet of tunnel advance. And when you say you're using it in production, you're actually drilling and blasting and loading these tunnels, right? So, so we've expanded the sort of competitive group to people who have pieces of the technology for 5 meters, other than just ourselves, to work together with a mining partner. And it went quite well until we got to the point where we really had to get 30 or 40 rounds under our belt to move from the sort of R&D phase to the, I would say, production robust, which we were being requested by the mines. We started that earlier this year. I know I'm not really alluding to the sort of CapEx and OpEx conversations because most of the funds that were put together by the partners were actually done internally. And I was only involved in bringing the group together rather than actually their internal funding. And for us, we were self-funding our part, using some of our consulting income to cover that. COVID hit in January, and by March, most mines, going along similar to my partners there, had pulled their horns in because their larger worry became, yes, improving their operations, but actually just keeping production going. So anyone who essentially didn't have their hands on the minerals had to leave the sites, and they had to get that house in order first. However, we were considered a critical project by the mine partner that we're with for the year, and we were called back, allowed back on site, or negotiated ourselves back on site with terms that lowered the risk to the operations. So minimum amount of people, only a certain amount on site, isolated test area, etc. And I still consider us extremely lucky to go back on. We're in OpEx, which means we're just the mine's covering consumables and the rest of us are covering our bits and pieces. But what I found is that they are actually becoming more robust in their confidence, where they've succeeded, I should say, in their anti-COVID risk and managing of their risk. So a good chunk of their engineering staff, their own personal staff, etc., are still working from home. And you're only really dealing with the miners on the face.
Yeah.
And now we're looking at actually continuing and finishing off the first part of the 5 meter cycle by the end of March next year. And I'm starting to feel more and more confident, rather than worrying about being kicked out every day, that the process is actually working really, really well around COVID. So
that
would be about it.
Thank you, Ron. You bring up a really good point, and I'll go back to Jack and Amanda to answer if they wish. Strategic partners can be helpful in pulling through young companies in difficult times. And do either of you want to elaborate on an example of how that's working for you?
Yeah, so we're actually right now in the middle of formalizing those agreements. So I can't say, who those partnerships would be with, but some of the partnerships that we're looking at are with OEMs potentially, and also with technology solutions integrators that operate on a global basis.
So we're actually going the other way, not working with OEMs, because what we're trying to do is make the technology available to a mine that would, say, have ground tools that they might buy from an OEM or from aftermarket somewhere, or they might have castings that they buy from many different places. And they would like to treat a lot of these components simultaneously so that they can get an economy of scale. So strategically, what we're trying to do is go directly to the mines. It's a much more laborious process. It takes longer. It requires more effort to be able to make that market penetration and to make that awareness. And we don't get the benefit of scaling up as fast. However, once we get a a customer, they're fiercely loyal because the metrics are easily seen as they see what they have saved in the operation using deep cryogenics.
Okay, thank you. This one we'll let go to a hand up first to start. Again, you know, I invest in a lot of very early stage companies, and we're familiar with is it the jockey or is it the horse? You know, is it the product or is it the leadership conversation? I think in COVID, at least in my own portfolio, the companies that already had a plan B and whose plan B had a plan B and C, you know, are really doing okay. And I'd love to hear from any of you, just by raise of hand, if you want to share with us some of your contingency planning and whether that worked or did not work for you in this unforeseen time. Amanda.
Yeah, I can talk about that. So, I mean, we didn't have a plan for COVID before it happened, but what did happen to us is that, so a lot of our hottest leads were in the oil sands. We had a lot of really promising prospects there that looked like they were going to convert like very, very quickly. And they just full stop, you know, put on the brakes when COVID hit. And so what we did was we thought, okay, you know, we know what's happening in oil right now is not good. That's not the case for every commodity. So where else can we look, you know, outside of Canada? Because it used to be that you had to meet people in person to do business with a mine, right? That was just expected. It's such a relationship-based business. But now, you know, nobody wants to meet in person. So what that meant was that we could actually start forging those relationships with people internationally in ways that we would not have been able to before without getting on a plane. And, you know, so that actually has been working really well for us, adjusting who we're reaching out to.
That is a great example. And when you think about how old and traditional mining can be, that it takes a pandemic to kind of convert it from a face-to-face business to one that can accelerate with electronic relationships. Anyone else? Just by ways of hand, I'll call on you. Want to? Yes, Jack.
So I had the great fortune of running a business very poorly in response to an unanticipated crisis back around the year 2002 with a dot-com crisis. And I found myself with 35 employees and lots of equipment with very, very high debt service and very scattered without a very good target and focus on where my customer base was going to come from after the original base was gone and my market had been eviscerated. And so I watched myself burn through capital very quickly and scramble at the same time everyone else was having the same issues. And the dot-com crisis back then in many ways mirrored as a smaller entity what is happening today with COVID. It's much more international. It affects so many more layers and more people and different industries. So when we started this business, I was very clear about reducing our debt service, our overhead expense, and targeting the type of customers that would be somewhat more impenetrable in the case of this. So we moved in our technology more towards mining and away from oil and gas. We love the environmental posture of mining today and the absorbing of innovation on digital platforms and on hardware. So we saw that it was a good fit, and we were better positioned, I think, because we had our backside bruised a little bit years before.
Experience is a wonderful teacher, right?
Yeah, no kidding.
Let's hear from Rod on this topic.
Yeah, so past couple of years, similar to Jack, we had a couple of experiences with gaps in the development. And so we actually went back to our roots, the consulting and the process improvement for the mines. And I don't think at the time we realized how much emphasis we should probably put in it, but that was our stopgap. When we came into March of this year, As Amanda said, the mine closed down, stopped dead while they worked out their COVID reaction. Then the first thing was to go back to what we knew, which was to consult, and actually then realized we actually have a repeating pattern. We need to deliberately expand. And the other part was similar to Amanda, is how do we get set up, make the most of the situation and get set up for sales going forward? Because that's our goal, is to actually have the 5-meter cycle, which proves the technologies and our technology in particular by Christmas. And we ended up going from a development plan to actually a video grab plan. And all our work is actually focused more around making sure that we can visually represent in video the entire cycle. In the background, we're gathering the data, the time cycles, etc. But basically gearing up right now for presenting a sort of video on the process and results for sales come Christmas.
Excellent. Well, 3 great examples of agility with these companies. You remind me of one of the favorite sayings too in companies: cash is king. So now I'd love to invite you each to share one of your favorite burn reduction or runway extension strategies from the last 6 to 8 months. Just by show of hands, I'll call on you if you can think of one. I'm putting you on the spot here. You may not have one, but Amanda.
Well, I mean, travel was a huge cash eater for us, and that it took zero effort at all to take that off the table. So that made a big difference for sure. Another one was we have relationships with cloud computing providers, and we negotiated with them for some additional cloud credits so that we could spend less on that.
So one of the things we did was at the same time COVID hit and most of our customers stopped both the deep cryogenic treatment of parts as well as also investing in customer paid research and development, we were able to access a tremendous program in Canada, the scientific research and development, the SHRED programs. So without even skipping a beat, we've managed to continue doing all of our scientific research and development and our field testing specifically on customer parts. So what we did was substitute, in many cases, the type of technology development, the D in the R&D side that we're involved in. We started moving that development directly towards customer parts, but substituting the support that the government of Canada was providing to us. So we really didn't have much of an interruption. We were just surveying out there for those types of programs before it hit.
Okay. And Rod, he went back to his roots with consulting. Maybe you want to expand a bit on that. That's a great cash generator at a time of need.
Yeah, and timing is always important, right? So we have another project, R&D project, that we're developing for a local client in the potash mines in Saskatchewan. And the timing was exemplary in the sense that we'd actually just finished a new design and we're moving into the fabrication. And as Amanda said, you don't really want to go to the labs that you're using, so spent a lot of time online, a lot of design time working with the engineers. And that's how we geared up at the R&D, the remote R&D project for the summer. And in the background, we used the revenue from that to make use of the data we had from the first 3 months of the year at the mine site underground with the remote loading technology to extend, I like the term, extend the runway. In hindsight, I think we were being fairly cautious on what we were going to contribute to the 5-meter cycle in terms of capabilities of our technology. So we did a lot of software hardware development over the summer in the workshop with our personnel to actually implement a much more aggressive data gathering technology capability gathering cycle. And that's actually where we're at since September testing now.
Terrific. So I think we probably have about 5 minutes left, and I'd love to take everyone's imagination away from the just survive and get through it place to from resilience to recovery, re-entry. So how about if everybody leaves me with their vision for whenever people are buying again, people can go to work as normal, and now you're having to compete to stand out in the marketplace. So give me a hopeful vision for the future re-entry. Rod, you want to start us off?
Oh, absolutely. Obviously, by Christmas, we would like to have wound up our sales work and our data in the background. We're focusing quite hard now on preparing people for that, clients that we have, mining companies. But we're also expanding, as Amanda had alluded to, there are a couple of OEMs that are starting to pay attention because it's a much bigger market than we could take on by ourselves. Manufacturing alone would probably be done better by someone else than by us. So we're actually spending time ramping up to go into hard sales for the version of the ARM that you've seen. The other thing we're doing with the partnership is it's getting set up now because there is a high level of interest amongst the OEMs and the mining companies that we're working with. And they've got differing requests to start the R&D late next year as a team on the complete teleremote version. And it's not because we want to postpone the sales, far from it. But I think it further helps people see where they could go with the same technology updated next year.
Okay, thank you. And I saw Mark popped on. And Mark, do you want me to do a time limit on these last two answers, or do we have a minute each for them?
Have a minute each. Carry on.
Okay. Who's next? Let's go with Jack.
I'll speak up. So we see that as the mines recover and they're starting to send us components to be deep cryogenically treated and starting in on research for key critical parts that if they could make them last longer, it would be an impact on their financial bottom line. We see ourselves moving directly from there into the scale up of very large tanks that might be located proximal in regional places in Ontario and Alberta, so that cost effectively we can treat parts on site or near mine sites, and so that it shortens their logistics tail and allows them to do more work without having to necessarily go long distance to us.
Fantastic. Thank you. Amanda, take us home.
All right. So something that both Rod and Jack referred to is the importance of proof. And given what we've seen so far in North America, our average savings estimated in maintenance and downtime for a single 350-ton haul truck are about $80,000 a year just for the one asset. And so we're in the process of proving that in North America right now. And what we're really looking to do is to prove that in additional regions over the next year. And so we're really looking forward to that.
Great. Back to you, Mark. Thank you, panelists and presenters.
Thank you, Angela. Thank you to you, our presenters, Amanda Truscott, Rithmik Solutions, Jack Cahn, Deep Cryogenics, and Rod Steele, TesMan. And to you, our moderator, Angela Jackson, thank you for your time and preparation. Thank you to our attendees for your time today. Go to the company websites and learn more about these companies. If you have a lead for them or a question, do connect. Now let's bring on Grace Pedota of CSE for closing.
Thank you, Mark. And thank you to our presenters. You did a great job today. And thank you for everyone for attending today. This episode was brought to you by Mining Over Canada, and have a great evening.